Hello everyone, this is our experiment number 4 in which we will be converting decimal to binary, binary to decimal, hexadecimal to octal, octal to hexadecimal and decimal to hexadecimal. So we'll start with decimal to binary conversion. In this I'll echo enter the decimal number, I'll read the decimal in which a variable binary will be holding some null kind of value. While the decimal is not equal to 0, it will be in the loop. In this loop, what I'll do is I'll get the last digit of the decimal number. For example, if it is 123, I'll divide it by 2, and whatever remainder is there, if I divide it by 2, that will store in bit, and this will be appended to the binary. Okay, and this whole value will be stored in binary, and subsequently decimal will be divided by 2 in every loop, and slowly decimal will be decreasing, and if it becomes 0, it will come out of the loop and the binary value will be printed. So let us check how this program works out. Actually, this program can be done using ibase and obase, but this is for just showing how this conversion works using shell scripting. We are doing this. Okay, there are simpler ways of doing this conversion. So let me enter a decimal number for, let's say, 18, and as you can see the binary value of 18, so 0 is 1, 2 plus 16, 16 plus 2 is 18, so this answer is correct. Now let us check the second conversion, that is binary to decimal, and let us see the logic in that. So binary to decimal, I'll get the binary value, and I've initialized decimal as 0, and so what I'll do is I'll get the binary value. When I divide it by 10, whatever remainder is, I'll get it. I'll multiply that whatever remainder is there with 2's power. For example, in the first bit it will be 2 power 1, so 2 power 0, that is 1, and in the second loop it will be 2 power 1, that is 2. In the third loop it will be multiplied by 2 power 3, and whatever bit values, for example it is 1, it will be 1 into 2 power 0. If it is 0, 0 into 2 power 0, and every time it will be added to the decimal bits. Okay, and every time this binary will be divided by 10, and is will be, that is the power, it's kind of a power function, it will be multiplied by 2, and after it is binary is less than 0, then it will come out of the while loop and it will be like, oh, decimal value will print the value. This is how binary to decimal conversion works. Let us see how it works, how it executes. So binary to decimal, so let me enter 1111, let me enter 4, this value is f, no, as in it will be 15, I guess. So let us see, so it is 15. Okay, so this is binary to decimal. Now let us see a third, and that is octal to hexadecimal. In this, first octal number is converted to decimal, and that decimal number is converted to hexadecimal. Let us see the procedure of it. So what we are taking, we are taking an octal number, we are converting this octal number to decimal. It is similar to that of octal. This is similar to that of binary to decimal. Okay, in binary we multiply that with 2. In this case we will multiply with 8. We'll get the decimal value. We'll give this decimal value as an input for decimal to hexadecimal conversion. In that, the decimal value will be taken. Each hexadecimal value as in 10, 11, 12 will be assigned a. So when I divide it by 16, I'll get a remainder. For example, if I get a remainder 10, then that bit will be marked as a. If I get a remainder as 12, as 11, it will be marked as b, subsequently till 15. If it is not like that, it will be that bit itself, and I'll append that with hexadecimal, and I'll put that in a hexadecimal variable, and in every time to decrease the decimal value, we'll divide it by 16, and if the decimal value is less than 0 or equal to 0, it will come out of the loop, and then only we'll print the hexadecimal value. Okay, let us see how it works. the octal to hexadecimal. Let me just enter some value 158, and this is the hexadecimal value of it. Okay, now let us do our hexadecimal to octal conversion. This conversion is based on O base and I base. In this, what we'll do is the output base is 8, that is octal. The input base is 16, and I'll print the value. Just I have to take the value hexadecimal and dollar hexadecimal, pipeline operator BC. Okay, let's see how it works. So let me enter the hexadecimal value, for example, say let's say A, and the value is 12 for that. Okay, for octal, not for, if I convert it to decimal, it will be 10. So we'll see that also in our next question. So this is the code for that. It is similar to that of octal, decimal, and decimal to hexadecimal. So I've taken the decimal to hexadecimal out of that code and just kept it here. So this is how it works. It's already explained in the previous question. So let us check how it works out. So this is decimal to hexadecimal. So let me enter a decimal value, for example 10. That will give me A. Again I'll print it. Let's say 15. It says F. Let's see what happens with 16. 0 1. It will start again. And this is how decimal to hexadecimal conversion works. I hope you have enjoyed this video. Thank you for watching. Have a nice day. Bye bye.